Today we're going to look at the law of cosines. The law of cosines is based on the Pythagorean theorem, which says in a right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse, a squared plus b squared equals c squared. But what if it's not a right triangle? Then what? So I'm going to develop the law of cosines similarly to the way I developed the law of sines. So you want to get this into your notes and just follow along, and that way you can see that, again, it's not just a made-up formula, that it actually has a basis for its existence. So here's my triangle. Again, it is not a right triangle, and so I labeled it ABC, a little differently than I labeled the last one. My altitude is dropped from vertex A to the opposite side, and so therefore that's why this is denoted here as a right angle, because I now have two right triangles. And side opposites are C and B and A. This one is based on Pythagoras, though, which means that a squared plus b squared equals c squared. Here's the problem. I need individual labels for this piece here, so that when I'm talking about triangle 1 and triangle 2, I can talk about these two parts. So what I'm going to do is call this part here x, and I'm going to call this part, let's say, I'll do it in, I'm going to pick a different color. I'm going to do it in green. Here. Now if the whole thing is A, and this piece over here I've labeled as X, then this piece here I can label as A minus X. Now my identity, or my Pythagorean theorem, says, and let's do triangle number 1 first, a squared plus b squared is c squared. So in triangle number 1, I'm going to use x for one leg, h for a second leg, and b for the hypotenuse, because that's how it's labeled. So it'll be a squared plus b squared equals c squared. So I'm going to have x squared plus h squared equals b squared. In triangle number 2, over here, same thing. I'm going to have a squared plus b squared equals c squared. And in this case, c squared is labeled c, or this hypotenuse is labeled c. I'm going to use these two for a and b. So I'm going to put that over here for triangle number 2. It'll be h squared plus x minus, or a minus x squared equals c squared. So all I'm doing is substituting these labels into Pythagoras for the two right triangles. Now, what I have common here, what you'll notice, is, we'll do light blue this time, this and this, common to both. So I'm going to solve this equation here in triangle number 1 for h squared. And what I will end up with is h squared equals b squared minus x squared, because I'm just going to take this term and subtract it from the other side. Now that I have an h squared representation, I could solve over here for h squared and then set them equal to each other. But in this case, I am simply going to substitute in to this formula for h squared. Because if h squared is the same as b squared minus x squared, then I'm going to replace h squared over here with that b squared minus a squared. A little bit different process than I used on the last derivation, but that's okay. So what's going to happen here then is I'm going to end up with b squared minus x squared, there's my h squared, plus this piece here, which is a minus x quantity squared, equals c squared. Okay, So now what I'm going to do is multiply this out here, this binomial squared, and rearrange my terms a little bit. So I've got b squared minus x squared, that just carries along, plus, this is what I'm going to do, x minus, or a minus x times a minus x. I'm going to FOIL that out. So what I will end up with is b squared minus x squared. When I multiply here, I'm going to get plus an a squared. I'm going to have two terms of a negative ax. One's for the outer and one's for the inner. So it's minus 2ax. And then when you multiply negative x times negative x, you get plus x squared equals c squared. Now, what I have here is a negative x squared and a positive x squared, which are going to go away. So rearranging my terms just a little bit, I have a squared plus b squared from these two terms here minus 2ax equals c squared. Now you can see that this kind of looks like the Pythagorean theorem. I've got my c squared, I've got my a squared, plus my b squared here. It's just this piece in here that's the extra bonus, if you will, and that's because it's not a right triangle, or I'm not sure if it's a right triangle. And so this is that adjustment piece for dropping the altitude and making the connection between them. The problem is this right here, this x. And so if I go back to my diagram, now I'm going to redraw it only because I can't go backwards, but you have it in your notes, so you can just refer back. So this is what the original diagram looked like that I took all my parts from. And what I need is a representation for this piece here, this x. And so if I look here on my diagram, what I can do is tell you that x can be found by taking the cosine of angle C will be equal to adjacent over its hypotenuse. And so if I multiply both sides by b, I can tell you that x will be equal to b times the cosine of c. And then I can do a substitution. So I have a squared plus b squared minus 2a, and instead of x, I'm going to replace it with this. b cos c equals c squared. And this is the law of cosines. Okay, now good news, it's also on the reference sheet. So it's going to be given to you probably like this. C squared equals a squared plus b squared minus 2ab cos c. And actually, you know what, now that I think of it, it's not. What they're going to give you is, because again, it is a generic formula, or general formula, doesn't matter what the labels are, they give you a squared equals b squared plus c squared minus 2bc times the cosine of a. This is the way it's written on the formula sheet. Here's what you need to remember. Doesn't really matter how, again, the triangle is labeled. The key is this little piece here, this side, is opposite whatever angle is being used. So in the law of cosines, you're only going to know one angle. And whatever angle of reference you're at, the side opposite, notice that's the only place you're going to see an A. In fact, if I go back to my original equation, or law, if you will, what I had was c squared equals a squared plus b squared. Now again, that starts out looking like Pythagoras, minus 2ab, which is these two legs again, times the cosine of C. So again, this little side and this angle are the pieces opposite each other. And so that's how you know where to start. It doesn't matter what you label the sides. These are general or generic formulas. It used to be that they gave all three possibilities. They also gave b squared equals a squared plus c squared, because if that's the side we know, then the other two sides are the a and the c, minus 2 times a times c times the cosine of b. So again, whatever you have here and here need to be the angle on the side opposite. Here's the deal. What if the triangle's not labeled ABC? What if it's DOG or PIQ or RTS or whatever it happens to be? Then what? So we don't want to have all those different versions of the law of cosines. It used to be that the Regents gave these three versions on the reference sheet. And now they've cut back to just this one. And they expect that you understand exactly what that means. Exactly what that means. So here's a quick example. I have a triangle. I have one angle labeled, and that is the clue for law of cosines. Law of cosines only uses one angle and three sides. Notice there's only one angle in there. If I had two angles, I would use law of sines. One angle, three sides, one angle, and the side opposite. That's what you need for law of cosines, because this is now going to be my A. And notice I didn't have any labels on there before, so I'll call this A. It doesn't matter which one of these I call B and C. It's an A, not a C. Okay, so when I plug it in, I know that I start with the side opposite the angle that I have, which is 35 degrees. So this is going to start out x squared equals. Then my two sides, 8 and 17, go in next. Either order, doesn't matter. 8 squared plus 17 squared minus 2 times 8 times 17. So again, what you see, the B and the C, you're going to see them again here. So we're going to B squared plus C squared, and then we're going to multiply them and double it and subtract it, okay, times the cosine of 35. Now this is the easiest kind, because notice what I'm looking for is on the left. This whole thing can get just dumped right into your calculator. Left to right, start to finish. Don't piecemeal it. Don't stop. That's what I recommend. Order of operations is huge here. And when people get these wrong, it's because they've punched it into their calculator incorrectly. What I will tell you is just go left to right, punch it in exactly the way you see it. I think you should try it, because you want to make sure that you're doing it right. So if I get a value for x squared, it'll be 130.190644. Again, don't get rid of your decimals. We're going to square root this now. So x will be equal to 11.4 to the nearest tenth, which is pretty typical for us in terms of, rounding. Again, you just got to pay attention to the problem. So this one here I call plug and chug, because you're plugging in the numbers and you're just chugging out an answer with the calculator. Here's another example, perfect example for law of cosines, because it's giving you the information. You got to build your triangle, put the stuff in, and know what it is you're finding. It's telling us that three sides of a triangle measure 18, 19, and 24. So I'm going to draw myself a triangle. And again, the scale doesn't matter. Just draw a triangle. We've got 8, 19, and 24. They want me to find the measure of the largest angle to the nearest degree. I know that the largest angle is opposite the longest side, so I'm going to put my x right there. Now, again, there's no labels on this triangle, A, B, C, whatever. Keep in mind your formula. A squared equals B squared plus C squared minus 2BC cos A, and you're going to pull that right off your reference sheet. So again, no need to memorize it. Although many of you will, just through use, get it memorized. But there's no reason to have any of these signs or any of these labels wrong because it is on the reference sheet. Keep in mind now that the angle here being used is opposite this side. I need to find that side. That's my starting point. So if this is angle A, this is the only angle being used, I'm going to call that A, which makes this little side A, which makes that my starting point. So when I start my formula, I start with the 24 squared equals. Now that's the only time I'm going to use that 24. So now I have my 8 squared and my 19 squared. Again, either order, addition's commutative. Minus 2 times 8 times 19, and that's going to be times the cosine of x. Now this one you got to be more careful because you can't just do plug and chug. This piece here, this piece that I'm trying to isolate is actually multiplied. It has a leading coefficient. So I need to take this in smaller steps. So when I square, you need to be very careful because 24 squared is your 576 and et cetera, but this piece here needs to stay as one chunk because of this product. Okay, it's very tempting for people to want to simply say, oh, 64 plus 361 minus 304 and combine this all into one term. Can't do that. Keep in mind, if I asked you to add 2 plus 3, well, plus, it doesn't matter, 4x, you would not get 9x. You would get 5 plus 4x because these are not like terms. Same thing here. These are not all like terms. So what I'm going to do is combine these. So I get 425 when I add 64 to the 361. And then I'm going to actually subtract that from both sides. 425. Because these are like terms. They're all numerical. What I'll end up with then, so I have 151 equals negative 304 cos of x. Be careful to not lose this negative right here. A lot of, it's easy to miss it, oversight. You want to make sure that this is always negative. So now what happens is when we're dividing both sides by negative 304, in order to clean this up, this ratio here is going to be negative, and that's okay. Keep in mind, when the cosine ratio is positive, that means I'm in quadrant 1, and my angle will be acute. If the cosine ratio is negative, that means I'm in quadrant 2, and my angle will be obtuse. Okay, so this is an important piece for you to understand. The signs are critical. So I get this decimal, 151 divided by negative 304 gives me negative 0.4967. I wrote a couple extras. When I inverse cosine, it's close to the negative 1 of this ratio, I should get to the nearest degree 120 degrees. It's 119.7826, but it's 120 degrees to the nearest degree. And that is law of cosines.